guys just get back? We are going to just do a couple examples from section 1.1 in our book, just talking about solving linear equations to get us back in the groove, get us thinking for the day before we jump in with anything else. When you're solving an equation, we know that means you're finding the value of a variable, right? But sometimes you have equations where you have multiple variables. So I just want to see if you remember how to manipulate an equation to get a certain variable by itself. Okay? So let's see where we're at, what we remember. If I told you to solve this equation for t, I equals PRT. So no numbers, I'm not going to get a number example or a number answer. I just want to know, how do I get the t by itself? What do? Divide. What do we have to divide by? E and R. And we can do that at the same time. It doesn't have to be two separate steps. It's all multiplied together. So t equals I over PR. Let's try another one. Hello. You have a mismatch. We just did one example where it's practicing manipulating equations and getting a variable by itself. All right, so this one's a little bit different. The first one was pretty simple. To get t by itself, we just divided. What makes b harder? There's two p's. So when I tell you to solve for p, I can't have p be a part of the final answer. I need p equals something with no other p's over there. So where should we begin? If I said you had 5 minus x equals 3x, what would you do first? Add the x over. So we would probably add this p over. Hello, Austin. Okay, the difference is these aren't really like terms, so I can't actually combine them. But at least all my p's are on one side now. Alright, here's a real test of your memory from last year. It's been a long summer. They both have a p. Hey, come on in. You have a mismatch. I just did one little example. So.
I have a notebook. I need to think.
Yeah.
Okay.
Sorry. Or I can give you a piece of paper to write on.
Yes, please.
So if I can't actually add them, can you think of anything else I could do to get those pieces together? No problem.
Factor out the p.
Yes, very good. Factor out the p. Okay, so if I take that p out, so in the first term, if you take out the p, you have the RT left. Plus, if you factor out the p here, what are you left with? A 1. Very good. Now how do you get p by itself? Divide. It's p times this whole thing, so we can divide by that whole thing. So our p is equal to a divided by RT plus 1. I promise my handwriting will get neater, but I haven't written on my slate in 3 months, so it's taken me a minute to catch back up. Okay, so that one had an extra trick to it. Are we okay with that? Let's could try this one, solve for x. Give it a shot and see how far you get. Alright, so let's see. We distribute the 3. And I have a 6x minus 15a plus 4b equals 4x minus 2. We are trying to solve for x, and we have 2 of them, so we need the x's on one side and everything else on the other. So if I subtract over my 4x, that will give me a 2x. I don't need the 15a, so we can add it. I don't need the 4b, so I'm going to subtract that. So I have 2x equals -2 plus 15a minus 4b. And you might have those terms in a different order, and that is totally okay. And then what to get x by itself? Divide by 2. You could leave it like this. You could have divided each term and wrote -1 plus 15 has a minus 2b if you want to break them apart. Terms can be in a different order. Lots of equivalent answers here. Alright. Any questions on that one? Let's do this one. You probably don't need to write down this whole problem. It tells us a trapezoid has an area of 169 square inches, a height of 13 inches, and a base of 19 inches. Find the length of the other base by first solving this formula for b sub 1. So this is the formula for area of a trapezoid. Now technically we could plug in the numbers first and then solve, and that's probably your gut instinct and what you would normally do, and that's great. But since we're practicing manipulating these equations, I'm going to make you do it the other way, just for today. If I wanted you to get that b sub 1 by itself first, what would you want to do about that 1/2? You can divide by 1/2, but we don't really want a fraction in a fraction. So it's equivalent to just say I'm going to multiply by 2. So it'll give me a 2a. 1/2 times 2, that just gives us a 1. Okay, so then what would we need to do? Divide, get rid of our h. And then base 1 is equal to 2a divided by h minus b sub 2. Could you have up here distributed the h first and then solved it? Yeah, so there's different options that are equivalent. We just found one form. So now, if I wanted you to find this base, we could go through and plug in. The area is 169. Which variable is that going in for? Okay. The height was 13. That's our h. And one of the bases was 19. Okay, you guys are welcome. You can grab a calculator if you need it. Check my mental math. guys get 7 inches for the other days? Alright, do we need more practice kind of manipulating these equations, getting a variable by itself? We'll do 2 final problems. Why don't I just go ahead and put them up and I'll let you guys work for a second, see how far you get, and then we'll talk about them together. Let's kind of see, I know not everybody's done, that's fine. The first one, it looked like most of you subtracted the 2w over. So you had p minus 2w equals 2l. So if you divide by 2, you could have it as p minus 2w divided by 2. You might also have written it as p over 2 minus w. Those are equivalent, so either one is fine. The second one, we have this 5/9 in front. You can distribute it, or we can just go ahead and move it to the other side. How can you get rid of that fraction? Yep. So if we multiply by the reciprocal on each side. So 9/5 c, those will cancel, equals f minus 32. So you just add over the 32 then on the end. Any questions for me there? So this is just kind of to jog our memories, kind of refresh us a little bit about manipulating equations. I have some time, so I'm going to go ahead and start the next section, which is the first real section we're doing. These are just some introductory problems. And we are going to jump right in with everybody's favorite word problems. Okay, we'll get it over with. Do it at the beginning and move on. I did not print out the notes for you, but I am posting on Google Classroom a typed handout with all of these word problems on it. So if you don't want to try to frantically copy the whole problem down, you can just make yourself a note that the problems are on Google Classroom. That way, if you want to go back and look at the problem and your worked out solution later on, it's there. Does that make sense? We are not just going to rush through this section. I'm going to do maybe 1 problem today, maybe 2 if I really have time, and we'll pick up with it and we'll continue working with this through a lot of next week as well. So when we solve problems, I think some of the biggest problems with when you have a word problem, you try to read the whole thing and expect yourself just to get to the end and know magically what to do. And it doesn't always work. Most of us get to the end and we don't know where to begin. So I have some steps that we're going to do as we work through these problems to kind of make sense of them and hopefully get everybody past. It seems like everyone's terrified of word problems, so let's try to work past that phobia. We can do it. Break it into pieces and make it doable. The first thing I'm going to ask you to do is, if you are going to be writing equations and solving a problem, you have to know what your variable stands for. If I get to the end and I have x equals 4, but I don't remember what my x was, that doesn't really help me. So the very first thing I'm going to ask you to do every time is identify the variable. Tell me, either draw a picture and label this is x, or write out in words what x is. If you do nothing else correct on your problem, I will give you a point just for telling me what your variable is. Likewise, if you get the whole problem right, but you never told me what your variable was, I'll take off a point. So I have to know what your variable is. The second thing, I don't want want to try to solve equations with x's and y's and z's in them. I only want one variable. So if there is more than one thing that we don't know, we will put it all in terms of one variable. Third step is setting up a model or an equation. And we'll solve it, make sure our answer is reasonable. And the last thing, if I give you a problem in words, I want you to answer in words. So we will write a sentence at the end. Alright, if the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. Find the dimensions of the original square. You guys have any idea what to do? No, you can't just read the whole problem at a fast pace and get to the end and expect it to work. That doesn't make any sense. So let's go back and read it sentence by sentence. If the length of each side of a square, let's pause. What am I dealing with? Square. What could we do? Draw a square. Oh, that is not a very good square. Hope yours is better than that. Okay, the length of each side of a square is increased by 3 centimeters. What does that mean? Okay, it got bigger. We added 3 to it, right? So I got a new square. So let's say this is the old square. And then my square got bigger. Okay, do I know how long the sides were in my first square? So what could I call this? X. Guess what we just did? We defined our variable. I know now that x was the side length in my old square. And in my new square, what happened to it? Increased by 3, so x plus 3. And because it's a square, we know all the sides are the same. That's the second step. I didn't call my new square y. I put it in terms of the original variable. All right, let's go back. The perimeter. What does perimeter mean? Add all the sides of the new square. So I'm adding all the sides of the new square. So you have 2 options. You can write it out x plus 3 plus x plus 3 plus x plus 3 plus x plus 3, which certainly works. Or what's the other option? Yeah, we have 4 identical sides, so you could just take it times 4 for the perimeter. So the perimeter of the new square is, yes, is that magical word that means equals. 40 more than, what does that mean? Yeah, it's greater, so we're increasing, so we're adding. So 40 plus twice the length of each side of the original. 2x. Twice the side, so side is x, so twice that would be 2x. Okay, we've done all the hard work now. Is this an equation we can solve? Absolutely. So if we distribute our 4, in terms of the amount of work shown, you guys are coming to the point, it's up to you. If you want to write minus 2x on each side, you can, if that helps you. If you can skip that work step and you just want to go to the next one, that's fine. So you guys show me what you need to show me. So you can subtract this 2x over, subtract over our 12. So we get 2x equals 28 divided by 2, and x is 14. Okay, am I done? No, what's my final thing? We have to have a sentence. Go back and make sure you know what the question was. We wanted the dimensions of the original square. So the sides in the original square were, okay, the original original, that was just my X, so 14, what were my units in this? Centimeters. 14 centimeters long. Or you could say the dimensions were 14 centimeters by 14 centimeters, or something along those lines. Any questions about that problem? So I cannot stress this enough. When we do word problems, I am never going to read the whole problem and expect to know what to do. I am always going to read just a few pieces at a time and figure out what that means. So we're stopping here today, no homework or anything. Tomorrow, make sure you bring your stuff. We will do some more of these problems. I might give you a couple out of the book to try on your own tomorrow.